Now continuing with the previous discussion of intersection of a line and hyperbola, here we now derive the condition for tangency. That is, how do we know quickly whether a given line is a tangent to hyperbola or not. So if you recollect, we got a quadratic equation in the previous slide. So continuing further, the line will be a tangent if the discriminant of this quadratic equation is 0, right? So therefore let us write the discriminant. We get 4a raised to 4 m square c square minus 4 into b square minus a square m square into minus a square into b square plus c square, correct? Just write this carefully, there are a lot of terms. Okay, now what happens is the middle term becomes positive because of two minuses, and we can cancel out 4 as well as a square from that, and therefore what we get is a square m square c square plus b square minus a square m square into bracket b square plus c square, which is equal to 0. So therefore let's expand the multiplication of two brackets. We'll get b raised to 4 plus b square c square minus a square m square b square minus a square m square c square equal to 0. We will see that the a square m square c square term gets cancelled, and from the remaining terms we can easily take b square common, which leaves b square plus c square minus a square m square in the bracket equal to 0. Now clearly b square being a positive number, we can cancel it from both sides, and finally we will get c square is equal to a square m square minus b square, and hence at the end we have c to be equal to plus or minus square root of a square m square minus b square. So this is that precise condition of tangency. That means if we are given the equation of the line y is equal to mx plus c, and if we are given the equation of the hyperbola, we know in standard form, then we can immediately check whether a line is a tangent to the hyperbola or not a tangent if this condition is met or not met. Okay, so that's the condition for tangency.